It's alive! Oh, this is gonna be nice. Hi y'all, thanks for tuning in. So last time you guys saw me, I had the system almost ready to go. Since last time, I got the DSP hooked up, I got the system playing, however, I did not run a lot of power through it. I'm going to save that for later. First thing what I want to do is spend the next few weeks building in all of the safety systems I mentioned earlier. As you can see, this is no joke. 400 volts. If you get shocked, it will stop your heart and you will die. Okay? So please don't try this at home. This is for entertainment purposes only. Maybe you might learn a thing or two. You might find it interesting, but I do not encourage you or support you trying this at home, okay? As far as I know, I'm the first one to do this. I'm taking risks. Please don't do this at home. Alright, so let's talk about what I want to do over the next few weeks. I mentioned I'm going to have a ton of different circuits that I want to build in here. Basically, I want to monitor the incoming voltage from the car, the outgoing voltage to the amplifier. The entire 12-volt subsystem will have its own DC to DC converter with a buffer battery, circuits in there for safety and monitoring and all kinds of stuff. Additionally, I need to build, first up, a pre-charge circuit. So in high current DC applications like this, what you have is you have capacitors in the system. This amplifier has two capacitors with a total of 900 microfarads of capacity. And the problem is when you first turn the circuit on, you have 400 volts rushing to those capacitors that are basically acting like a short circuit. They will fill up with energy as quickly as possible, and they get stressed. You do this enough and you risk damaging and blowing them or having them leak and damaging the other circuitry. So that's something that I want to address immediately. And to kind of prove the point here, let me turn the main battery on. So the idea is, as soon as I turn this breaker on, 378 volts is going to rush into there, fill up the capacitors, and stress them out. The way we're going to be addressing that is through a custom circuit that I'll build on a PCB and install in here. And it's going to be called a pre-charge circuit. Pretty common in high voltage DC circuits. And it'll be controlled by a timer, by a relay, and a few other things. And it's going to pre-charge the system. Once the system reaches nominal voltage, a contactor will switch over to the main line and then turn off the pre-charge circuit. So I'm going to build all that circuitry and install it and basically have you guys follow along if you're interested. But just to show the concept here, I have this clamp meter on the negative side. And remember, the electrons flow from the negative side of the battery to the positive side. A lot of people think it's the opposite, but in fact, what you have is negatively charged particles and positive. So the negative flows through the wires down into the positive. So it's not backwards, FYI. This is why we put it on the negative side. So we could actually see the electrons flow into the amplifier, and then they get built up in the capacitors, and they don't go back through the positive into the battery. If you were to clamp the battery, you would see absolutely nothing because the electrons are flowing in through the negative and just chilling there in the capacitors. So basically, let me turn on the system again. And let's watch the clamp meter spike. Because it's not a very good tool. There's much better meters and other tools you can use to do peak holds and whatnot, but this should exemplify the concept. There you go. Actually, the breaker tripped. Now, that was 970 microfarads at 400 volts rushing in. This is a 100 amp breaker, and the fact that it tripped means 300 to 400 amps worth of power went through it into the capacitor. Now you can imagine 400 amps, if you do the math at 400 volts, is a ton of power. It's like 160,000 watts. Having that flow through in a few milliseconds is really not good for the components. So that's why first up, that's one of the first things I'm going to be building. Hopefully this is interesting and you follow along. So please share with your friends that are into car audio and they want to see kind of the cutting edge here. And I hope to keep this fun for everybody. Thanks for tuning in.